Afternoon. Today we're going to look at how to create equations, rational equations from word problems. Uh, Most often what we'll do on an exam is I'll ask you to create an equation, and then I'll ask you to solve another problem like I'm going to do here based upon a problem, but I wouldn't ask you to create an equation and then solve it. And that would be the same thing if you had had a diploma this year. So here's a basic word problem. Lyle can fill a bathtub using cold water tap in 8 minutes. When both hot and cold taps are open, he can fill the tub in 6 minutes. I've given you an equation. We will be asking you to create these equations later on. What is the time in minutes required to fill the tub using only the hot water tap? So here's the equation that has been developed. Now we're just going to solve it using our skills that we've practiced before. I need to multiply everything by 8t because that's my common denominator. And we end up with an equation that reads 60 plus 48 is equal to 8t. 48 is equal to 2t, t is equal to 24. Now, we want to go back and check our work. So we have 6 over 8 plus 6 over 24, 3/4 plus 1/4 equals to 1. So we have checked our work with this. Now, this is a rate problem. We'll be talking about that a little bit later. But we are going to do most of what we're going to be doing is speed, distance, time problems for this. And this equation, time is equal to distance over speed, is basically the version of what we talked about in grade 10. Speed is equal to distance. Grade 10 physics or science, speed is equal to distance over time. Manipulate that, we end up with this equation. Because we're doing rational equations, a lot of our problems are going to have to be dealing with time. So this is not a necessity to do solving problems, but it is a very, very useful problem or way to do this. Keeping track of what we have, create an equation over here, time is equal to speed, distance below speed, or distance over speed, I should say, is equal to time, and figuring out the equation from there. So here's our first example. Jerome rows his boat 2 kilometers downstream and then back to where he began. When the average speed of the current is 2 kilometers, Jerome can complete the journey in 9 hours. So what we have is the distance that he rows downstream and then upstream is 2 kilometers each way because he's going down 2 and then coming back 2. Okay. Now, when he's going downstream means he's going with the current, or like what I did this morning, I'm going with the wind. So the wind is giving me a push, right? So we have a 2 kilometer per hour push if his boat is going in this direction. Okay, so his speed will be however fast he can row the boat, which I'm going to say let be s plus 2 kilometers. So let s equal to speed he can row. Define our variables so you remember what they are. So when we look at time here, the time it takes him to go downstream 2 kilometers is 2 kilometers over s plus 2. Now, when he turns his boat around, he's rowing against the current. So however fast he rows, minus the 2 kilometers per hour that he needs to push against the current. So we have 2 over s minus 2. Now, this chart is going to allow us to do the problem that we want. I really wish that would stop. write an equation to model the situation. So let's go back to what we have. He completes his journey in 9 hours. So he goes down 2 kilometers, and then he turns around and comes back 2 kilometers, and it takes him 9 hours. So that's our total time. And that's going to be equal to the time going downstream plus the time going upstream. Now, we can probably figure out it's going to take him longer to come upstream than it is to go down. We know the time going downstream. We had that at 2 over s plus 2. We know the time coming upstream. On our chart, 2 is 2 over s minus 2, and the total time is equal to 9. And that would be a problem that I would ask you, right? What is the equation for this situation from there? Now, solve for his average speed. This is definitely going to be a much more difficult question than what we normally see because the equation that we get is not factorable. I am going to go through it with you though. We are going to do exactly what we kept doing before. I have to multiply everything by s plus 2, s minus 2, s plus 2, s minus 2, s plus 2, s minus 2. So that and that cross off, leaves me with 2s minus 4. That and that cross off. Oops, sorry. That and that cross off, leaving me 2s plus 4. And over here, we're going to have 9. And then s plus 2, s minus 2. Please remember that we have to draw a little bit of a face. S squared minus 4, 2s plus 2s. This one would be minus, so what we end up here with x squared minus 4. We have 4 s's equal to 9s squared minus 36. And because we know it's a quadratic, we've got to get everything to that. Now, like I said, this is most definitely a problem that I would probably not put this on an exam, and I don't think it would have been on any diplomas this year. This is not factorable, okay? So I'm going to use the quadratic equation to factor this, which is x is equal to minus b plus or minus the square root b squared minus 4ac over 2a, where this is a, this is b, and this is c. So we have minus -4 plus or minus -4 squared minus 4 times 9 times minus 36 all over 2 times 9. Now, this works out to be, once you plug this in, we have 2 possible answers for this. We have 4 plus square root 1312 over 18, or 4 minus 300 square root of 1312 over 18. So approximately we have positive 2.23 and negative 1.79. Now, the negative does not make sense in terms of this problem. He can't be going backwards. He can't be rowing backwards. I guess he could, but it does not make sense in the terms of this problem. Now, like I said, I would probably not put this equation, solve it. I would find this equation, But because it's not factorable, I probably would not put solve that on any type of assessment that I give you. Okay? And another one here, you will notice that Mr. Hovey doesn't put the entire question down. St. Andrews Student Council is traveling from Knoxville to Harperville for a national conference. Based on the travel budget, they have two options. One thing we have to do in here, which I didn't put in, the total distance is 1,500 kilometers. You can leave by bus at night or leave in the morning traveling by train, which will save them 3 hours. And the train travels 25 kilometers an hour faster than the bus. Okay, so I'm going to define stuff. Now the distance, doesn't matter if you go by bus or go by train, you have to travel the 1,500 kilometers to wherever they were going. Now I'm going to define the speed of the bus as I happen to like X, whatever. Okay, if the train travels 25 kilometers faster per hour faster, then the speed of the train will be the speed of the bus plus 25. So the time it takes them to get there by bus is 1,500 over X. The time it takes them to get to by train is 1,500 over X plus 25. Okay? So this is interpreting what the information in the question states. Now, to write the equation. Okay, so we know that it will save them 3 hours traveling by train. So that means the train will take less time. Okay? So there are several ways to set this up. We have to think about it. The train is going to take less time. So if I have the speed of the bus, take the speed of the bus, that's the slowest. Speed of the train is the fastest. Now we got to figure out where to put that 3. Okay, and it doesn't really matter. If this guy is the slowest and this guy is the fastest and they have a difference of 3 hours, I could put the 3 there. The slowest speed minus 3 hours is equal to the fastest speed. Now I also could do it this way. The slowest speed is equal to the longest time is equal to the shortest time plus 3 hours. Okay, so I'll change that to maybe longest and shortest. So the shortest time has to have 3 hours added to it. Or I could have put it over here, take the longest time, subtract 3 hours. There are a couple ways of writing it. I'll just leave it like this. Okay, so that is the equation that would describe the system that we have here. Now, to determine the speed of the bus and the train, we'll just go ahead and solve what we have. Okay, so we have denominator of x plus 5, and a denominator of 1. So again, just like before, we need to multiply by x plus 25, x plus 25, x plus 25. So that crosses off, that crosses off there. We end up with 1,500 x plus 25 is equal to 1,500x plus 3x times x plus 25. Now we just have to solve this equation. It's going to give us another quadratic. Well, this is factorable. 1,500x plus 37,500 is equal to 1,500x plus 3x squared plus 75. are 1,500 x's. If I subtract them from both sides, they disappear. We have another quadratic, so that means everything has to go to one side. Subtract 37,500 from both sides, 3x. We lose an x there, please don't do that. And then minus our 37500. Take out a common factor, 3, x squared plus 25x minus 12500. Now the two numbers that multiply to 12,500 and add to 25 are x minus 100 and x plus 125. So terrible board work. Our solutions are x is equal to 100, x is equal to negative 125. Now, again, this doesn't make sense. Can't have a speed of negative 125. So x is equal to 100. Well, we have to answer the problem, speed of the bus. Is equal to x, so that's 100 kilometers per hour. Speed of the train is 100 plus 25, so 125 kilometers per hour. So, again, this is very, very important for you to fill out, getting the equation. So, let's do one more. I will do, let's do 2, yes. Air Airlines is a fleet of airplanes whose average speed is 4 times the average speed of the derailleur passenger train. A derailleur train requires 12 hours more than Aaron's airplane to travel a distance of 2,000 kilometers. So, and again, in both cases here, we have 2,000 kilometers for our distance traveled. This question says, I'm going to call the speed of the train S. Now, and that makes sense in this case because we're not adding. Has an average speed who's 4 times the average of the train. So if this guy is S, this guy has to be 4 times S. That gives us our time to be 2,000 over 4S, which is equal to, because it makes the question a little bit simpler, 500 over S. This guy is 2,000 over S. So there's your problem. We've got an expression to represent the time it takes to travel 2,000 kilometers for both of these. Now we have to interpret, if we want the equation, we need to interpret the rest of this. A train takes 12 hours more than the airplane to travel that distance. Okay, so we have the slower train is going to take a longer time. So that slower train is 2,000 over S. The shorter time is 500 over S. Now we got to figure out where we put the 12 hours. Okay? The longer time is 12 hours more than the shorter time. We put it in any place we really want, but we have to get the right sign. Take the longer time minus 12 hours, and that's going to give me my shorter time. Okay? There's our expression, or there's our equation. This is why I put the longer time and the shorter time, because I still make these mistakes if I don't look at it very, very carefully. I'll put that 12 in the wrong place. I did it earlier today. Now, to solve, hey, we have just a nice S as our common denominator. So we'll have 2,000 minus 12s is equal to 500. Okay, basically multiply every term by s. We have 1,500 is equal to 12s. S is equal to 1,500 over 12. And my brain's not working quite as well. Should have figured that out. S is equal to 125. Now, what the heck does that mean? Well, let's go back up here. We said the derailleur train speed was s. So s is 125. So that means s is 125 kilometers per hour. That's the speed of the train. The speed of the airplane is 4 times or 125. So the speed of the plane is traveling at 500 kilometers per hour. Okay, so that's that. You are asked to do for homework, and I'll go over these questions with you when I get back. You have the whiteboard work 3, 7, 8, 9, and then homework 9, 13, and 18. So 3 here, 7, 8, and 9, which is exactly the same thing. And then we had 9 here, 13, and 14 there. I shall see you tomorrow.